Hi everyone, we're from Group 3 and now we're gonna present about application of radio wave in radar system. So please pay attention on our explanation.
So for the first question is what kind of system do you like to review and why do you choose this system? So our group is choose the radar system. Why? Because radar is a system that has been used in aviation and maritime affairs in communicating between aircraft and outside parties, our tower, other aircraft, or ground station, and the most important electronic navigation equipment in shipping. And then, because the radar system uses radio wave in its operation, the radar has many advantages over LiDAR or sonar.
Hello everybody, my name is Safira Khairunnisa and right now I will explain to you about what are those advantages. The first one is radar system can detect relatively small targets at near or far distances. And the second one is radar system can measure their range with precision in all weather. So these are the chief advantages of radar when compared to other sensors. And the next one is longer sensing range, and we can compare it to LiDAR. So radar has sensing range is 128 kilometers, but LiDAR only have a few meters to more than 200 meters. So the difference is very big. And the next one is in comparison with classical pulse waveform, radar has a low measurement time and low computational complexity for a fixed high range resolution system requirement. And the last one is potential for lower cost realization. We can compare it to other alternatives such as sonar or LiDAR. So the cost of radar system varies from $50 to $200. But we can take an example from LiDAR. LiDAR has the cost of around $23,000. So the difference is very big.
Hi everyone, my name is Frecia Mardianto. About how does the system work? But before that, let me introduce the component of the radar. So radar in the basic form have four main components. There are a transmitter, as you can see in the pictures below, and a transmit or receive switch. It tells the antenna when to transmit and when to receive the pulse. And an antenna will send this pulse out into atmosphere and receive the reflected pulse back. And the last one is a receiver, which detects, amplifies, and transforms the received signals into video format. The received signals are displayed on display system such as television or any other electronic screen. And radar output generally comes in two forms, reflectivity and velocity. Reflectivity is a measure of how much precipitation exists in a particular area. Velocity is a measure of the speed and direction of the precipitation toward or away from the radar. But most radars can measure reflectivity, but you need a Doppler radar to measure velocity. But there is the important equipment in the radar apparatus. So it's called a duplexer. And duplexer will match the antenna switch back and forth between the transmitter and the receiver. So while the antenna is transmitting, it can receive and vice versa. So this is how does the radar work? So first is magnetron generate high frequency radio wave. But I want to tell you magnetron. So the radio wave used by radar are produced by a piece of equipment, we call it magnetron. So the wave a magnetron produces are actually microwave, similar to the one generated by a microwave oven. But the difference is that the magnetron in radar has to send the wave many miles instead of just a few inches in microwave oven. So the magnetron waves is much larger and more powerful wave. So the second is duplexer switch the magnetron through antenna. So the antenna will act as transmitter, sending narrow beam of radio wave through the air. And radio wave will hit enemy airplane and reflect back. So the antenna will pick up reflected wave during a break between transmission. But at the same time, antenna act as both transmitter and receiver, alternately sending out radio wave and receiving them. And duplexer switch antenna through to receiver unit. And the computer and receiver unit process reflected wave and drop them on the TV screen. And the last one, step is enemy plane shows up on TV radar display with any other nearby target, and the display radar will watched all the time by human operator.
Okay, the next one is basic principle of radar. Radar makes use of phenomenon we have all observed, which is echo principle. Usually, in the form of electromagnetic signals radiated by the radar are pulse modulated. It can determine the distance to a target by measuring the time that required for an extremely short burst of radio frequency energy to travel to the target and then returning back as a reflected echo to the receiver. As you can see from the picture here, the incoming wave, the blue ones, is going to the right, and when it hit an object, it will reflect it back to the left as a reflected wave. There are two main operation principles, which is continuous wave, or usually we call it CW, and pulse. Radar systems are composed of a transmitter that radiates electromagnetic waves of a particular waveform, and then a receiver that detects that specific waveform echo that returned from the target.
Hello, my name is Erina Rizkia. What are basic principles of physics used in radar? Only a small portion of the transmitted energy is re-radiated back to the radar, which is then amplified, then converted, and processed. The range to the target is evaluated from the traveling time of the wave. The direction of the target is determined by the arrival angle of the echoed wave. The relative velocity of the target is determined from the Doppler shift of the return signal. As we can see in this figure, there are two systems in radar. The first is monostatic radar. There is duplexer component from transmitter and receiver, and the second is bistatic radar. There are two separated antennas from transmitter and receiver. Next is continuous wave and frequency modulated radar. First is Doppler radar, a classical continuous wave or CW or Doppler radar implementation uses a fixed transmit frequency to detect a moving target and its velocity. It is based on the Doppler frequency shift. The frequency is equal to 2V divided by C multiplied by frequency 0. And then we can get the velocity is equal to VA multiplied by cos theta. The theta is from the angle. And then the second is frequency modulated radar. A simple continuous wave radar allows determination of target velocity, but not the distance to the target. Therefore, a frequency modulated continuous wave or FMCW system have been developed to resolve this drawback. The frequency is equal to frequency B, it is stationary, and R is equal to 4B divided by T or period multiplied by R divided by C. So that the equation from R is equal to C multiplied by frequency B1 plus frequency B2 multiplied by T or period divided by 8B. And then the velocity is C multiplied by frequency B2 minus frequency B1 divided by 4 frequency 0. And then the delta frequency is equal to 2 divided by period or T. So from this equation, we can get the delta velocity is equal to C divided by 2 frequency 0 multiplied by delta frequency. It's equal to C divided by frequency 0 multiplied by 1 per period or T.
Okay, next is drawback of radar system. First, radar takes more time to lock an object because radio signal travel fully in air and space. It takes more time to get to the object and back. Second, radar has a wider beam range and it was a shortened range because the beam of range for radar is quite wide and not target specific because radar signal operate at limited range at 200 feet. Third, radar can be infrared by several objects and medium in the air because the radio signal face plenty of interference from the air while traveling to and from an object. Fourth, it can resolve targets that are obstructed by a conducting material because radio signal have challenge with maneuvering material that are conductor. If an object is behind such material, it's difficult for it to obtain the data regarding the target. The data provided by radar system are usually not complete because the complete data is due to the fact that the signal will not report every detail about the target. It cannot differentiate the color of the object. Radar system will get all the information regarding an object but will not provide data regarding the color of the target. comment regarding the radar system. The radar system uses radio wave as the basic of the process. By this system has an easy but complex working principle. The system has advantage and disadvantage. The system is indeed widely used in most remote monitoring systems, but there are also some drawbacks such as not being able to display a good image and their area of signal capture and capture objects that are less detailed. On the other hand, this radar system is very affordable option when compared to another system, other such as LiDAR. Okay, that's all the material from the VR group, and thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh. Thank you for watching.